I want you to imagine with me that we are journeying on a quest into a not-so-ancient framework. And as we venture inwards, we discover an underground tunnel. As we wander cautiously and bravely down deeper into this great work of art, into the dark underbelly of this view monument, we find ourselves staring deeply at a document there, and slowly a picture starts to emerge. And if you're feeling adventurous, I would like to help us all truly understand and decipher this ancient document that you might have seen in the view documentation, so that someday we might all understand the brilliant language of Evan Ra, the deity of sun and code. Hi, I'm Greg Pollock, and this is the start of our Advanced Components course here on View Mastery. In this lesson, we'll be building a reactivity system. The goal is to better understand Vue.js. We'll learn some of the Vue design patterns that we'll see when we dive under the hood. We'll start thinking about watchers and what those mean with Vue, as well as this dep class, which we'll build ourselves and we'll see again inside the Vue source code. Let's jump into it. Here is a simple Vue application. You can see we have data, we have computed, and here's the template that goes along with this simple Vue app. Now Vue somehow knows that when our price updates, we want to update that here in the template and here in the template, as well as this computed property is going to get updated, which is going to update it over here in the template. So the question is, how does Vue know how to update all the things? In this lesson, we're going to be building our own reactivity system to begin to understand how this might work under the covers. And it starts with understanding that, well, this isn't how JavaScript usually works, right? So we have a price and a quantity for our example. We have a total. And if I log this out, I'm going to get total is 10. Now, if I change price and I log out the total again, what do I get? Total is still 10. But it didn't get updated, right? In a reactivity system, this would get updated. So our first question is, how can we save the total calculation so we can run it again when price or quantity updates? How might we implement this? Well, we need some way of saving this code to some sort of storage device like you see here. And whenever you see that red record icon, that means we're saving the code. Then we'll run the code after we've saved it, and later on we will need to be able to run the stored code again. And notice that little play icon. Every time we rerun code, you'll see that play icon in the future. And keep in mind, we may have lots of stored code that needs to get rerun when one variable changes. So let's jump back into our example. This time we're going to have a new variable called target, and our target is the code that we are targeting for reactivity. We're going to set that equal to our new target variable. Then we'll call record, which will save this code inside the target. We'll implement that function in a minute, but basically it'll send it into our storage. Then we'll go ahead and run the target. And then finally, sometime later on, when we change a variable, we need to run all the code that we've saved inside this storage device. Just so you know, there's a few ways we could code up reactivity, and we're going to be coding this in a certain way. So if it looks a little funky, just bear with me. This anonymous function that we're storing in target, there's another way we could write this using this syntax, using this more updated JavaScript syntax. We're going to be using that from now on. At one point in time, I heard a blogger refer to this as the hipster syntax. So we'll use the hipster syntax. So the storage we were talking about, let's add that as a variable and make that an array, like you see here. We'll implement the record function, simply pushing our target anonymous function into our array. Then we'll create our replay function, just going through each anonymous function inside storage and running it. Now, if we ran this code inside of our console and logged out total, we would get 10, as we would expect. If we change the price, we still get 10. But if we call replay, it'll rerun all of our save functions, and then when we log out our total, we get 40. The total was rerun, just like we expected. Next, let's create a more scalable solution, maybe creating a dependency class. and we'll use the observer design pattern. Here you can see we have a dep class that stands for dependency. In our constructor, we'll instantiate our storage, this time calling it subscribers because we're following the observer pattern. Then to save our target, we'll create a depend function. First checking to see if our target exists, and if it's not already inside of our subscribers array, we'll go ahead and add our target into our subscribers. The depend function is replacing our record function from earlier. Then the notify function will replace our replay function, going through each of our subscribers and running them. Just some foreshadowing here. Vue also has a dep class, which kind of mimics this functionality, which we'll see later. Let's go ahead and run this code. Here you can see we have our dep class, and inside the constructor we instantiate our subscriber storage array. We have our depend method, where we record our target. Then we have the notify method, where we play back each of the subscribers. And down at the bottom, you can see we create a new dep instance. Further down, we instantiate our price, quantity, and total, set the target equal to our anonymous function. Then we call dep depend to record our target, and then run our target. So if we jump into the console, we'll just open up Node. We'll load all of this JavaScript into our Node console. Now if we check price, it equals 5. Our total equals 10, as we'd expect. Now if we change price, our total doesn't change yet because we first need to run dep.notify. Now if we run total again, we can see that it properly ran our target and updated total. In our reactivity system, each of our variables is going to have different dependencies. So we need a way to encapsulate the code that's going to be watched or recorded as our targets. So here you can see our code from before. And we're going to create a watcher function in a minute that simply takes an anonymous function as its argument. And we'll use that eye icon every time we have a watcher function. Let's define it. Inside of our watcher function, we set the target. We call dep depend to record what's inside the target. We run the target, and then we clear it. Again, we're coding this in a particular way that will become clear when we add additional functionality. Let's go ahead and run this code. Here's our watcher function, which is setting the target, recording the target, running it, and then resetting it. Let's jump into Node and run it. Our total is 10. We'll change the price. Total is still 10. Now we call dep notify. That should rerun our total calculation. And it does. The total is now 40. As I mentioned earlier, each of our variables is going to need its own dep instance, so we can rerun all the functions it needs to. Let's visualize that. So we have our price variable and our quantity variable, and they each have their own dep class. We're going to move these into properties like you see here. It'll be a little easier and you'll see why. So if we have a watcher that has both data price and data quantity, this will need to be saved inside the price dep instance and inside the quantity dep instance. Then if we have another watcher that has data.price but not data.quantity, it only needs to get added to the dep instance for price. Now, we need a way to identify which properties are accessed inside each watcher to figure out which dep instance to call. So inside this first watcher, we want to be able to notice, hey, price was accessed inside this watcher, so let's call dep depend for the price property. Oh, look, quantity was accessed, so let's call dep depend on quantity and record the function there. Then inside this second watcher, we'll notice, hey, price was accessed here. We'll call dep depend on price. We also need a way to identify when a property gets updated, so we can trigger dep notify to be called on its dep class. Before, we had to run dep notify, but we need a way so that when price gets updated, when it's set, that we call dep notify on the price dep instance. So when we call total, we get back 40, and we no longer have to call dep notify manually. This is where object define property comes in. This allows us to define getter and setter functions on a property. So here's our object, and now we'll call define property on it. And from now on, we'll use this icon whenever we call define property. We'll send in the data object, specify our price property, and then inside we'll declare a new get function. For now, we'll just log out I was accessed to the console. We'll define a new set function, and we'll just log out I was changed to the console. Now, when we call data.price, it calls our get. So when we call data price equals 20, this calls our set function. And if we ran this code, we would see I was accessed, I was changed. You might notice this doesn't actually get or set actual values. Since we're overriding the get and set functions, we need to actually implement this functionality. Let's do that now by creating an internal value variable, which will store the value starting with our initial value. Then we'll log out the value we're getting and return the internal value. That will just be our current value. Then, when we call set, we'll log out what we're setting the price to, and then we'll actually set the internal value to this new value. Now when we run this code, we see getting price 5, setting price to 20, as we'd expect. We want to call define property for each of our properties in our data object. So let's do that now. We'll call object.keys to get all of the keys for our object, and we'll iterate through each of them. In case you're wondering, our keys return an array with price and quantity. We'll then set our internal value to the initial value of that property. We'll call define property for our current key. We'll log this out properly, and then we'll set it properly. Nothing else changes. Then let's see what happens when we total our price times quantity and then set the price. If we ran this code, the moment it called data.price, we would see getting price. The moment it called data.quantity, we would see getting quantity. And when we set the price, we would see setting price to 20. You might see where we're going. We're going to take these two techniques now, and we're going to combine them to create reactivity. I'm excited. Are you? Remember how we needed these dep functions to run at the right time? Right? Here's our watcher. And when price gets accessed, or get, we need to call dep depend on price. And when quantity is accessed, we need to call dep depend on quantity. And when price gets set, we want to call dep notify on price. And then when we call total, we get back 40 because we're now reactive. All we need to do now is put these pieces of code in the right places. So let's take these inside our object-defined property. We have our data, we go through each of our keys, set the internal value. Each of these is going to need its own dep instance. That's our storage. We'll call define property on each of them. Nothing new here. Instead of our get method, we'll call dep depend, because when our properties gets accessed, we want to add our current target to the subscribers. Then in our set method, we'll set our internal value equal to the new value and call dep notify. This will run all of our subscribers. Let's go ahead and run this code and see if it works. I'm excited. At the top, we have our data object and our variables. We have our dep class with our storage, our depend method, and our notify method to rerun each of our subscribers. Further down, we go through each keys of our object, get our internal value, instantiate our dep class, go through call define property. There's our get method. There's our set method. Further down, we have our watcher function, which is a little simplified. We just set our target, run it, and then unset it. And then down here, we have two watchers for running the total and the sale price. If we jump into Node, let's load up this script and see if it works. Our total is currently 10. Our sale price is 4.5. Now let's change price. Ooh, total got automatically updated. It's reactive, so is sale price. If we update our quantity, we can see that our total gets updated as we would expect it to. Sweet. Let's start thinking about how this might be implemented in Vue by jumping into this illustration. As you can see here, we have data getters and setters. That's using object-define property. When get is run on a reactive property, we collect it as a dependency and call depDepend on our dep class. And when our property is set, we call depNotify also on our dep class. Notice Vue also has a watcher. It's much more complex than the watcher we wrote, and we'll get there in future lessons. To review, in this lesson we built a simple reactivity system. We learned how to create a dep class which collects dependencies and reruns all dependencies. We learned how to create a watcher to manage the code we're running that may need to be added as a dependency, and we learned how to use object-define property to create getters and setters. Thanks for watching. In the next lesson, we'll see if we can find reactivity in the Vue source code itself.
Where do I start? In our constructor, we'll create our storage array. This was our, what did you say? In our constructor, we'll create our in our constructor, we'll create our storage array, as you would expect from the observer pattern.
Yeah, I think that's just so you have like,
Yeah.
if someone's like, wait, what is that from? They might be able to Google that.
Right. In our constructor, we'll instantiate our storage.
As I mentioned earlier, we need a way for our functions. As I mentioned earlier, we need a way for our As I mentioned earlier, each of our variables is going to need its own dep class so it can rerun all the functions it needs to, or that it depends on. Is it that way? No, it's the other way around. As I mentioned earlier, our variables are going to each need their own dep instance, so it can rerun all the function it needs.